Welcome back to the channel, everybody. My name's Matt Dickinson, and apologies that I have not uploaded anything about the Hardiman project for quite a while. We've been doing some really cool stuff with it, and what I wanted to do today is bring everybody up to speed with what has happened so far. So, since I last posted about the Hardiman project and the Hardiman rebuild project, I should say, or a fan-made project, or whatever which way you want to see it, one thing that we started to do is we started to generate components. We started to make parts. So the reason that we've done this is on the CAD that we have, we're able to really see where everything was and have a good idea about where everything sits. So there's a few things I wanted to do. Something I recently spotted, but I'm going to get to that a little bit afterwards within the documentation, which I find quite cool, to be honest. So let's bring this down a little bit and let's take you through where we are so far. So let's just shrink me right down, and what you can see there is where we are so far. This is the first version of that we've made. This is 3D printed out of PLA, or polylactic acid, for anybody who wants to be very specific. Then from there, I used some of the techniques that I'd actually found here on YouTube. Exactly who the reference was, I cannot remember, but this isn't me, and it was the idea of mixing 50% acetone and with so a 50% ratio between wood filler and acetone, mixing it up to create like a primer. Paint the primer on, and then its method for actually really sealing up some of them layer lines is incredible, absolutely incredible. So this is 3D printed. It is down to the geometry exactly as we got, and then what I've done is I've spread it, and I've now moved it to a bit more of the Hardiman look. And we're quite proud and pleased with the progress that we've got with this so far. What you can see there is everything is it's first been mixed with the primer and the filler to actually create that surface, then obviously rubbed down, and then it has been sprayed in black primer with a surface plastic or upper coating to give it the, if you will, the darkened aluminium look. And then it has a top face lacquer to give it a shine. It's just to give it a brushed look, but it's just for people to get an idea of what this will do. Now, why? Okay, so I did it. We've generated this one just because recently we did a presentation. Well, me and definitely the students did a presentation called Exoskeletons Past, Present and Future, and this was featured where we showed where we got to on the project so far, and it's just to get people an idea, or at least to know what's going on. And since then, our good friend Rita has reached out to the American Army, and who knows, you never know, let's see if they have any idea where the Hardiman is. What we're doing though is plowing on ahead with the project and trying to figure out more and more things. So what do we find? This is quite interesting. So I'm just going to zoom it in. So you kind of look and you go, okay, cool. That's cool. It looks like the part. Now, this back control box, we have learned so much by just printing this. It is crazy, absolutely crazy. So what I'm going to do is just take you through the bits that have gone wrong, why they've gone wrong, and how we intend to fix it moving forwards, and some of the changes that's going to be made with this, because this is now definitely a project on the move. It is on the go. It's exciting, but at the same time we want to make sure that we do it right. So let me just zoom in a little bit over here. So what we did is we were thinking about this. This is a control box. Your hand, the hand is going to have the master control system, which actually interfaces with the slave response. So the master control actually slips into this control box and engages so that you can move your hand, and then you can actually control the rest of the exoskeleton. When we printed this and actually put his hand into the back, your hand doesn't fit very well at all. So instantly told us this is good, you know, it's a good start, but it is wrong. The front end of the arm I'm quite pleased about, still looking pretty good. However, this control box we know for sure is not correct in this way. So what do I mean? If I just bring back up to the actual original design that we got, if anybody remembers, this is the overall design, and I'm going to just remove that for a sec here. And to make this a bit more visible, let's just bring on some lines. Let's bring in the lines. There we go. Right. So this edge here, this is too small. And also, what did we figure out? We figured out that if I just hide the control box, this was probably on a swinging arm. So it could probably move. The control box could probably move, and it wouldn't be constrained or constricted to the actual the ankle point here, not the ankle, the wrist of the system there. So that then led us a little bit further down the line, as if to think, well, how is this something that we know for sure? So what I'm just going to quickly do is just step into our Hardiman archive, and anybody who's involved in this project with me, you'll know how big this archive is now getting. It's getting quite big, just because we're finding more and more and more things about this. So what I'll do is, let's get onto the archive and let's get, so this is all the pieces and bits of evidence, anything that we've been able to find. So let's just zoom that in. Look at that angle there to the upper wrist here, and you go, okay, that looks almost in line, square if you will. So if we move on to the next, oh, not that. Okay, let me just come on to, there's one in particular where you can clearly see. Now, you look there, it's not 100% clear here, but you'll notice, see on the wrist point here, that is not in line. If that isn't in line, however, on the other, so that isn't in line, however, on, we will get there in the end. If you look here, but you look there, on that one it is. And then if we just pan over to this, if we can see this. Oh no, it wasn't that one. I think it was actually on one of these drawings. Might have been on this. Ah, now there, you see there? And I was never sure about this, but you can see there, that seems to give the impression that is a swinging section. That's its own axis. So it can spin. So in other words, this section here that we have, as much as we're on for a good stab, that needs cutting out. This has its own entity, and this can swing around its own axes. So that's really interesting, and that showed what we had here to be incorrect in that process, but it is a very good move forward. So at the moment, this section needs updating. The thumb section is being presently worked on by one of the students looking at linear actuators for interfacing, and that's why I've just stepped back from this approach, because I don't want to skew anybody's ideas. So I've just stepped back from this for the moment, and I'm waiting to see what other people's ideas are on that. Okay, so where are we up to with the rest? Yes, so it is purely now on this point. What I'll do this week is I'm going to do a bit of a recording and just capture this on the live piece as well. If you do have any questions about this, if you are interested in my geometry and you want to get access to my archive, drop me a line in the comments, and I'm always open to people having a go and helping improve this design to get us back the lost piece of history, which is the Hardiman. And I recently learned some really sad news, which is that the control system that Moshe originally designed, as much as there is documentation there's so many unanswered questions, and sadly many people do believe it's been lost in time. We must chase this and must find where it is and get it back. So anyway, right, so that's where we are up to with Hardiman. So what is our next phases now? Again, all on the control box and adding this section in. I'll give you an update next week as to where that's got and how we've got with that. So what else have we found? This is quite cool. So this is the final documentation, and I've been combing through this left, right and center to understand more and more about it. Now check this out. So they refer to the modifications to the leg system, the operating. Now this is obviously the big problem, the legs. You couldn't walk in it. So then they go stop shields where were installed to test the fixtures, and this is purely because they knew for sure that if you were going to put this on, this could be incredibly dangerous. This could be a real problem. Test for the legs for initialized supporting the operation of each leg, joint operating independently was attained. Now this is where it gets interesting. Look at this. The serial operation, the multiple leg joints were attempted to operate a remote machine extension, handles from the master control. Now, what you start to do as you're reading through this, you'll note it actually starts to talk about. I'm just looking for. There is a ride along function. Here we go. This is what I was looking for. Apologies. So the approach was taken to fasten the legs to the system, to the slave, and support the operator seated and attached to the slave. So in essence, they knew that the legs were not working, and they couldn't get. I think, like many, you overshoot the complexities of somebody walking. The human body walking is very sophisticated. However, you cannot take away they actually did build the world's first. In fact, if you do want more evidence of this, check Guinness World Records. You will find Hardiman being the world's first powered exoskeleton. So, no arguments aside on that one. It's there. Even Guinness World Records has recorded it. Right. So, seated to attach to the slave. This enables an operator to control the leg system via an operator ride mode. The manner is similar to an operator pedal for a bicycle. Right. This is interesting. That is how the cybernetic anthropomorphic machine, the CAM, or walking truck, was used. So you had upper body where you were moving the front legs, and then you had lower body where you were moving the back legs using the same function. You were almost moving your legs like this and arms like this. So you were in that pedaled motion. And it's just interesting. I'm just really fascinated now. Is that the point where they were working on the CAM and then they got on here and then they realized, you know what, this system could work better for this? Is this the point where the CAM system was first proposed? Because what's interesting for the CAM is the CAM worked. The method worked. However, people were so tired by the end of it that it just was not a flourishing thing to do. But I'm just fascinated. Is that very first point? Is it these simple words where they came to, or was the CAM already established and they took that system and they went, right, let's put it on the Hardiman? I'm fascinated to try and find out. Because this documentation is just starting to just be so flourishing with so many little nuggets of excitement that's emerging from it. Because don't forget me wrong, the CAM system was 65 when it was proposed, but exactly when it was being tested, that's what I need to try and figure out. Because if I can find a direct alignment, you'll see where one fed to the other, and then everything led a little bit further. Yeah, the test arm. So somebody asked me recently exactly what is it that we're aiming to achieve with this project. I'm just going to take you right back to something that we learned. Let me just go. There we go. Let me just pan that back. So if I just go back to the reports, and I'm going to go to my list. We're going to go July 1969. So it's crazy now. I've done this so much. I actually know what one's what. So this on July 69 for the prototype test, and it's July. It is July 69. Just looking for something. So two things. If we just zoom in to this, notice here it is completely clear and we've got a shadow being cast there. I think that is almost instant evidence to show that our control box has its own axes to rotate around, and I think they all sit on a spindle, and that single spindle allows it to move. So what I would like to do, one, is I would like to work with my student groups, the student chapter from ASTM student chapter, and we're going to try and recreate the imagery that is here and try and rebuild some of these images. And the other thing is as well is this document was based on the Hardiman arm test, and when I say the Hardiman arm test, I'm talking about this one. So what we're going to try and do is recreate this section and see if we can do this by modern technology, by 3D printing, and see if we can actually bring a bit of the Hardiman back to life. It's super exciting, but yeah, that's what we're going to do with the project, and that's where we're going to take it, because even just doing what we've done so far on the Hardiman here, we've been able to learn that this must be open. This must be more in-depth open to what it is. So there's so much there. Anyway, so short one, trying to keep them short, trying to keep them super exciting. This project is still very much alive, super things going on, and looking forward to the next initial stages of this to show where we are in our next iterations. This project is still moving, and by the end of this year, our aim is to at least have this section of the arm completed, which is the front end section of the arm completed, and then we were getting that one step closer to building the actual arm. When we're moving on, I'll be taking more and more photos, and obviously I'll be getting more and more things about what we've been up to. The project itself shouldn't be that much far behind of a few other things as well. But anyway, if there is any burning questions about where we are up to with this, if you do in fact know where Hardiman is, do get in touch. If you want my geometry, just put a comment in. If you're a student and you want access to my geometry, please do just come and see me. If you want to join the student chapter, you want to get involved with what's going on, please come to the exoskeleton laboratory in the Engineering Innovation Centre at the University of Central Lancashire. Come and drop by and get involved with so many things that's going on. Other than that, I hope you found this update insightful and interesting, and I hope you all have a great day, and I'll speak to you all very soon. Thanks, everyone.